Okay, so let's try next one, 24. Same page. (3y minus z equals -1). X plus 5y minus z equals -4. (-3x plus 6y plus 2z equals 11. I start with the augmented matrix. Can anyone dictate the augmented matrix by rows or columns? It doesn't matter to me. Just tell me what you're doing so I know how to just write it. Exactly. Awesome. Yes. Awesome. Excellent. Now, do you see the reason why we would definitely love to swap? And what will I swap? Exactly. Of course. So I'm going to say row 1 becomes row 2 and vice versa. On the side, I explain every step I make. So row 1 becomes, row 2 becomes row 1. 1, 5, -1, -4. 0, 3, -1, -1, and -3, 6, 2, 11. Lucky us. We already have this and we already have this. Look at that. That's really nice. So in this first step, I multiply what? By what? Of course, I have to start with row 1, and I multiply it by what to add it to row 3. Excellent. Thank you.
Notice how you're doing by column, but is it possible so that we can also do?
Okay, let's go back. Very good question. If we deviate in any way, shape, or form, you mean to write the matrix?
No, I mean like
or to solve it.
Solving by
If
column.
we deviate from this sequence, we will never get the solution.
So
it's a must. No one can deviate from this. It's 1 and the corresponding zeros. It's 1 and the corresponding zeros. It's 1 and the corresponding zeros. There is no other way.
Oh no, I get that. I'm just saying like if I solve it for the first column first, I get 1, 0, 0, and then move on to the second 0, 1, 0.
No, 1, 0, 0. You have to get 1 and 0, 0. You cannot get this 0 based on this 1. You can only get these 2 zeros based on this 1. You cannot go sideways. So one more time, there is no deviation from the sequence. 1 in the upper left column and then the corresponding zeros. 1 in the middle and then the corresponding zeros top and bottom. 1 at the bottom of the third column and the top zeros. You cannot go sideways. No deviation from this method. Don't try. Very good point. Very good question. Very good point. I never thought of saying that. So if you hadn't asked that, I would have never ever thought of saying it. So it's awesome. Okay, we copy row 1. We definitely copy row 2. We are not touching those. So let's do this together. 1 times 3 minus 3. Perfect. 5 times 3. 15 plus 6. Very good. I don't like it. -1 times 2. Oh, we may run into fractions. It's very possible. Yep, it's possible. -1 times 3. -3 plus 2. Excellent. -4 times 3. -12 plus 11. Okay. So this is done. We have to work on columns only. Yeah. I have no choice. So I rather divide the middle by 3. Then swap 2 and 3 and divide by 21. So 1, 5, negative 1, negative 4. 0, 1, negative 1/3, negative 1/3. 0, 21, negative 1, negative 1. So what did we accomplish so far? We have this and we have this. My next target is this. So what other answer to Mana's question is this? Remember, when we multiplied the whole equation and we added it to another equation. We cannot simplify x and y and z. It's a very good question, actually. Okay, good. So now I have to use row 2 and add it to row 1, row 2 and add it to row 3. But what do I multiply by? For the first one, negative 5 to eliminate the 5. And for the second one, negative 21 to eliminate the 21. Indeed. That's a mess.
Will we ever have to subtract instead of multiply?
No.
I mean, instead of adding?
No, because remember the elimination method? We multiply one equation and we add the result to the second equation. Yeah. Okay, together, please. Ready?
We copy the second row first.
Yes, we copy.
And the 1, 0, 0.
Very good. So these cannot change. Those are done. So now, 1 times negative 5 plus 5.
0.
Excellent. Negative 1/3 times negative 5 on the side, that is 5/3, but I have to subtract 1, which is 2/3. Is that clear? Negative 1/3 times negative 5 is 5/3 again, but now I have minus 4. Remember, 3 times negative 4 is negative 12. Negative 12 plus 5, negative 7/3. Okay, next. This is nice because now I'm multiplying with a multiple of 3, so that will not be a fraction. So 1 times negative 21 plus 21. Excellent. Negative 1/3 times negative 21 is 7. Positive. Positive 7 minus 1. Excellent. The same thing here. Positive 7 minus 1 is 6. Okay. What would be my next step? Yes?
1.
Exactly. So I have to divide row 3 by?
3.
Good. Yes, but she knows it's 6, so that's why I wrote 6.
I look.
I know. 1 0 0 1 0. I'm sorry. See? Don't rush. It's 0 1 0. Good. So now 1 1. We agree with 1 1?
Yeah.
So negative 1/3, 2/3, negative 1/3, negative 7/3. Obviously, this is the last step, so we have to use which row? There is no doubt that we have to use row 3. Multiply by something to get to row 1. Multiply by something to get to row 2. So let's look at the method one more time. In the first step, we use row 1. In the second step, major step, we use row 2. Now we have to use at the final step. We have to use row 3. Is this clear? Do we see that? Okay. So now, I multiply row 3 by what to eliminate 2/3? Excellent. I multiply row 3 by what to eliminate negative 1/3? Excellent. Are you with me so far, everyone? Okay, this will be the last step. It's like a puzzle, I would say. Which page am I on so I don't mess them up?
Oh.
I think this is 8. Okay, ready? Final step. 1, 0, 0, 0, 1, 0, 1. And 1, of course. So 1 times negative 2/3 plus 2/3. 1 times negative 2/3 minus 7/3.
Plus 9/3.
So it's negative
Or
9/3,
minus 9/3.
which is
Minus 3. You divide that.
1 times 1/3 minus 1/3. Excellent. 1 times 1/3 minus 1/3.
0.
And this may not be correct till I check. I don't believe anything. So what is the solution?
Negative 3, 0.
Negative 3, 0, and 1. Okay, with a question mark, I don't know. I'm only hoping. Okay, so back to the original problem. Negative 3, 0, 1. 0, 1, negative 3, 0, 1, negative 3, 0, 1. Ready? 0 minus 1, negative 1. Negative 3 plus 0 minus 1, negative 4. Positive 9 plus 0 plus 2, 11. I'll say yes.
Do you have a class after this thing?
Yes.
Any teaching this?
Yes. You're more than welcome and invited, and I would be honored to have you.
I think I'm staying for that one.
Absolutely. Any questions? Okay, do we continue with another problem?
Another one of these? Yeah.
Or we finish with 8.1?
Let's finish with 8.1 so we can start something.
Okay, and that is the last topic of the entire semester. We're done.
Will that be enough in 15 minutes to do 8.1?
Yes,
Okay.
I think so.
I know it went quick.
I know I talk a lot, so sometimes.
No, it's like,
No,
one
you're.
day it went really slow, but today I'm like, where did the class go?
I guess we're all really focused on that thing.
Yeah, I was like, that's distracted enough. Yeah, there's like 15 minutes. Or almost like 20, but.
Okay, 8.1, sequences and summation notation. 8.1, sequences and summation notation. We start with the summation notation. I may not be able to finish the sequences, we'll see. Okay, what is the summation notation? So let's suppose, any questions? Any questions? Okay, let's suppose we have 1 squared plus 2 squared plus 3 squared plus ... plus, let's say, 10 squared. This is one way of writing the sum, right? However, there is a much nicer way and condensed way of writing this sum. So this is the first term, right? First term of the sum, correct? So we'll say when I is 1, I get this first term. When I is 2, I get this term. And then when I is...
10.
Exactly. So here's the notation. This is the Greek letter S.
Sigma.
Sigma. Sigma or summation notation. Very good. Sigma. Sigma notation. Or the summation notation. Of course, from I equals 1, from the very first term, this is an index. From the first term till the last term. What is the last term?
Oh, you
From
mean
I
it
equals
said
1.
equal
Just for
eight.
this one.
Okay.
Just for this one. From I equals 1 through 10. From what? Well, from I squared. So this is the condensed form, if you want, even an elegant form of all this. So how does this work? When I is 1, I have 1 squared. The summation notation means plus, plus. When I is 2, then I have 2 squared. Plus, when I is 3, I have 3 squared, plus dot, 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 exactly 3 dots, plus I go to the last term, which is 10.
So like the I squared part is like telling you what formula.
What to do, exactly.
Use, and the number
Exactly.
of tells you where to start and
Exactly.
where to end is up top.
I is the index. We normally use I, J, or K as index. 1 is the lower limit. And 10 in this problem is the upper limit. So it starts with 1, the lower limit, and it ends with the last one, which is 10 in this case. Okay.
What's the J and the K again? I'm sorry.
They're all indices. Normally the index is either I, J, or K.
Oh, okay.
These are the letters that are normally used. Can you use A and B? Of course. It's up to you. But we normally use I, J, or K as being the index. Okay, so can anyone explain what this means? How many terms, first of all, would you write? 4 terms, from 1, 2, 3, and 4. Can anyone give us the first term without calculating anything for everyone to see? Times 1 plus 1 squared plus.
3 times 4.
No
It would
calculations.
be 2 in parentheses 1. No, 2.
2 times 2 plus 1 squared plus. Can anyone give us the third term?
2 times 2 times 3.
Very good. Excellent. Plus.
Is there some handy little function on our calculator?
Yes.
Ooh.
So, since you asked, why not? I'm looking for it. Okay.
Is it the I above the decimal point? Oh, no, no.
Here it is.
I'm just looking.
Here it is.
Oh.
So in our case, we have x equals 1
How did you get there?
through math all the way down. Go to math all the way down to summation notation. And in our case, it's 4. Then in parentheses, we have 2x plus 1. Let me know if you found it, and the power 2. Before we hit enter, let's calculate just this one by hand, just once. So you already told me 2 times 1 is 2, plus 1 is 3, and 3 squared will be 9, plus 2 times 2 is 4, 4 plus 1 is 5, squared is 25. 6 plus 1 squared is 49, and plus 8 plus 1, 81. So let's see what we get. So this is 90, and this is 74. So I got 164. These are my calculations, and now I would like to press enter.
What was it called?
Summation.
But it went to like, you went second math, right?
Yes. No, just
just
math.
Oh, that's why.
Just math.
And it might be option 0.
Yep, there we go.
So 2 times 1 plus 1. 3 squared. Why am I not getting the same thing? Let me put the power in a different way. That may be the issue, because we have to get the same answer. Okay, I'm going to do this.
What was the answer we got?
576.
No, it's incorrect.
Is it 164?
Yes, of course.
Okay, so mine has it
Yeah,
inside parentheses.
Yeah, but that's what I said. I have to insert parentheses, yeah. And then put the square inside.
Mhm.
And then
Close the parentheses.
put another parenthesis, yeah.
Yeah.
It didn't like it.
Oh, it deleted your first set of parentheses. Because you put an extra parentheses.
Yeah, I put insert. I don't understand why I did that. I put second and insert and parenthesis.
Right.
And now I don't understand with this program why is the power so high. It shouldn't be that high, but anyway. Yeah, it doesn't like it.
That's weird.
Can you only do this with the calculator?
We already did it by hand a second ago.
Okay, wait, when you,
Yeah, we just did it. We just did it with it by hand before checking with the calculator.
Sure. Quite sure.
Thank you. Yeah, I don't know the software. Yes, it's perfect, but the software doesn't allow me to put that power for some reason. Any questions? Any questions?
So we should probably use by hand method instead of calculator.
Oh no, it's just the software is not working
Yeah, it worked out.
properly.
Oh, mine didn't work. That's why I'm asking.
So is this it? Or
Yes, this is the sum.
so
That's the answer. Yes, we just calculated by.
when I first started typing, it already had parentheses in there, and I went inside.
Yeah, but not in my case, not in
No,
the
I know,
software.
I was telling her,
Yeah.
she was saying that hers didn't work, but she looks like she was the same. Do you guys have TI?
No, you have to add parentheses to it.
Use 85.
Factorial notation. Before we continue, we have to discuss factorial notation. So if we encounter something like, let's say 4 factorial, 4 and the exclamation mark, 4 factorial, this means the product of the first 4 numbers. Can anyone tell us what will 10 factorial mean? 10, 9, 8, dot, 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 3 times 2 times 1. Okay, let's see how we simplify factorial notation. Like, for example, and I'll show you with the calculator as well. Let's look at 24 on page 752. And we have 18 factorial divided by 16 factorial. Any questions? Any questions on this? Okay. So we want to simplify. We're asked to simplify this. So I know that the top will be what? 17, 16, blah, 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 blah. But here's, I'm looking at the denominator, which is smaller. It's 16 factorial. So here's what I'm going to do. Why did I stop at 16 factorial and I didn't continue with 16, 15? Right, because I can simplify them. And the answer is just 18 times 17. So how do we do this with the graphing calculator? I think my software here will cooperate for this. Okay, you could, sometimes it will exceed, the number is so big that it may exceed the memory of the calculator. That's why being able to simplify it is extremely important. So let's give it a shot. I don't know. So 18 factorial. So go to math and go to probabilities and choose 4. 18 factorial divided by 16 factorial. Go back to math and choose, and on the probability, choose 4. I don't know if you're going to get the answer, hopefully, 306. But sometimes be careful. Certainly, if we are talking about something like 28, no calculator would help. 2n plus 1 factorial over 2n factorial. There is no way we can, at least as far as I know, maybe the new sophisticated calculators, maybe they do magic. Who knows? Okay, which one of these two is bigger? Is 2n plus 1 bigger than 2n, or is 2n bigger than 2n plus 1? Very good. So then the one that at the top, I will write it as, I have to start with the top, with the first one. There is no way. Times, what is will be the next one?
2n. The 1n? N plus 1?
2n plus 1 minus 1, which will be
0.
2n.
2n plus 1 minus 1 is 2n. And why do I stop at 2n factorial?
So you can't go out with the bottom.
So the answer is 2n plus 1. Yep. Any questions?
Why did you multiply? I'm sorry. Oh, you're good. Why did you subtract one? Like, why did you do that?
2n plus 1 factorial is 2n plus 1 times 2n plus 1 minus 1 times minus 1 times minus 1 minus 1 minus 1 minus 1 minus 1. Yeah, but because from 10 to 9, I subtract 1. From 9 to 8,
You subtract from
Yeah.
like the and
from 8 to 7, I subtract 1.
okay, you can't subtract
Yeah.
Wait, can you go put the paper like frozen?
You can't subtract from the variable, right? You couldn't take it the 2n and make
No,
it
from
1n.
2n, I subtract 1, and I can't subtract.
So the bottom where it said 2n, you couldn't have done anything else, right? Like that's the
Yes, of course I can. So 2n factorial will be 2n times 2n minus 1 times 2n minus 2 times 2n minus 3
like 2
times 2n minus 4 times dot 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 times 3 times 2 times 3 times 2 times 1.
Okay.
It's the product of the first numbers, and the biggest one is 2n. Yeah. Is that better? Is that clear? So from here, I subtracted 1. From here, I subtracted 1. From here to the next, I subtracted 1. From this to the next, I subtracted 1, and so on and so forth. But there is no need to do this because the numerator was bigger, right? And right after the first step, from 2n plus 1 to 2n, I stopped because these two go away. Better? Okay. So here is number 42. Find each indicated sum. The sum from I equals 1 through 5 from I plus 2 factorial over I factorial. Of course, I'm not going to do this before I simplify it if I can. If it's not simplifiable, then I have no choice. But is there a way of simplifying? Which of these two is bigger? The top. Very good. So I equals 1 through 5. So please tell me how to write the top. Excellent.
No,
I plus 1 times
I with the
factorial. Excellent. Great job. So now I have the sum from I equals 1 through 5, from I plus 2 and I plus 1. Can anyone dictate at least the first and the last term? And we can do it with a calculator, but I would like to write for everyone to see the first and the last term.
so 1 plus 2
1 plus 2
and
times 1 plus 1 plus dot dot dot. And can anyone give us the last term?
5
5 plus 2. Awesome. Times.
5 plus
Excellent. These are the 5 terms. Of course, we did not present the middle 3. So let's try with the graphing calculator. So go to math and scroll up. I think it will take me faster there to summation notation. So x equals 1, and it goes through 5. Let's see if I can do it. And in parentheses, x plus 2 and x plus 1. X plus 2, doesn't matter, the order is not important, but, and x plus 1. and close the parenthesis and press enter. I got 110. Okay, awesome. We get 110.
Oh, because I didn't put this there.
Any questions? Any questions? So I do have a little bit more to present here to you on Monday. So I don't want to forget